So basically, we can start up with, as we talked about earlier, distance that was supposed to be path difference. अच्छा, सही है. That's nice. Path difference between 2 points. अब आए हो तो रुक ही जाना क्लास में. So represented by D or S. Unit is meters. ठीक है. Nature is, it is a scalar concept or scalar quantity. Now, what does that has to mean? So let's understand this through an example. We can say a cyclist travels 100 meters. So this 100 is basically only magnitude or size or number. It is never telling us where this cyclist is going. Is he going north, south, east, west? We don't have any idea where he's going. It is only 100 meters. So there is no absolute clue about direction. So we don't know what direction is through this statement. So this makes this a scalar concept. All such quantities which doesn't specify any direction, which doesn't need any direction to be completely understood, they are scalars. ठीक है. Then इसके साथ we can have basically displacement. That's a vector. And the best possible definition is it is distance in a specific direction. Sometimes it is also referred to as shortest possible distance, but that may not be always true because we can have longer distances in a specific direction that will still mean displacement. Representation is the same as D or S, and unit is still meters. But as I told earlier, nature is, it is a vector concept. It is a vector quantity, which is only specified through a direction and a magnitude both. So a particular example can be this cyclist traveling 100 meters in, yeah, towards north, something like that. So this becomes value and this becomes our direction. Okay, so if anyone wants to take a picture, note it down, please do it. I have to change my slide so that you might not be able to see this. Okay, now, if we talk about practicing distance and displacement, we can discuss it through an example. So let's do an example. Let's say there is a car that, travels 100 meters and reaches A, from where it travels to B, which is 500 meters further. Calculate the distance traveled by the car. So basically, what we can do about it is that we have two of the distances here, which is 100 meters and which is a 500 meters. So total distance traveled by this car is going to be 600 meters simple. So understanding is we just added both numerical values. We never cared about their direction because we were discussing a scalar concept. So scalars are added or subtracted भी लिखना था, but वो बाद में लिख लेंगे, चले. Added simply without catering to directions. ये हमारा side note हो गया. ठीक है. But had the same question, been specifying some directions, let's say There is a car that moved 100 meters west, reaches point A, then from here, that car moved 200 meters, sorry, the east होना चाहिए ना भाई, north, and that's B, and then the car traveled 500 meters west. So, what is the total displacement of the car? If that's the question, so how do we solve it? How do we go about it? So we cannot do just like 100 plus 200 plus 500, right? Because this 100 is not only 100. This 100 is east 100, right? And then we have 200 meters, that's north. And then we have 500 meters, that's west. So the only possible way to solve this is, this question is to use vector addition. Okay? And we have to understand what that is. So I would request you guys to bring up a ruler if you have one. You have to bring a pencil and you have to have a blank page. Okay? Done? So before we solve into that, if you have a ruler with you, if you have a pencil with you, if you have a blank page with you, so please let me know so that we can continue. I'll wait for maybe 2, 3 minutes so that everyone arranges the stuff they have. Okay, so in order to solve this question, which says 100 meters west, 100 meters east, then it says 200 meters north, then it says 500 meters west. So what we can do is we can, first of all, we have to decide a scale. So keeping the available drawing area in my mind, what I'm planning to think is that the maximum length I can have on my ruler is 15 centimeters. Okay. So if I assume, let's say 50 meters as 1 centimeter, well, this would be then 2 centimeters. Let's go about 25 meters. Yeah. So if that's the scale, I can keep then 100 meters east would mean drawing a line, right? Drawing a line of 4 centimeters. This becomes 4 centimeters eastwards, right? So first thing is 4 centimeters east. Let's draw it. Well, that's done. Then the car traveled to 200 meters north. So according to the given scale, I have to draw now a line of how much centimeters? It should be 8 centimeters, right? So let's draw a line of 8 centimeters here. That's north, and that's east. So let's move ahead with that. Right? That's east, north, done. And then 500 meters west. Now, this one would then mean if we have 500 meters and we have supposedly a scale of 25 meters to 1 centimeters. So it would now be 20 centimeters, right? So 20 centimeters artwork. So is it done till here? Everyone has completed it.
Yes, sir.
That's nice. I am still waiting for a few students who have messaged me just to complete their answers. We have then 20 centimeters, 8 centimeters, and then this was where? This was north, and then we started off with east, 4 centimeters. So now if I am to finalize this is going to be 20 centimeters, right? And westwards. So it goes all the way like this. So now how would you measure the total displacement? Well, that's very simple. You connect the starting point to the final point. That is it. And then let me know the distance it measures up. Let's see how it goes. So if I'm doing out my on my tablet, it comes out to be total distance of 18 centimeters.
Sir,
Here.
17.8 for me.
That's nice. That's close. 18 centimeters almost. So we can accept answers all the way from 17 to 19. That's plus minus one ka difference. If your answer lies somewhere here, that's okay. That's acceptable. So, and yes, uh, we can show it here like north, but that's not compulsory because that's not needed here. But you can do it anyways. There is no harm in that. So has everyone completed it? Different scale would mean different length here, but the answer would still be same because if I'm having 18 centimeters here, okay, so for 18 centimeters, since my scale was 1 is to 25, so if I multiply it with 25, so my answer would be 450 meters, okay, because I have to multiply it with 25 based on this scale. And so will your be answer, 450 around your answer should be. Okay, regardless of this length, because if this length changes, so is this scale, and then the final answer still comes out to be same for everyone. Okay,
Sir,
yeah,
445
that's good.
meters.
Yeah, that's good. So Now, what I wanted you guys to understand here is, see, we cannot just add 100 plus 200 plus 500. Why? Because each of these numbers is not only a number, they had a specific direction. So we cannot just add them up simply, right? That's what is different with the vectors. So now what you have done here is you have worked out the displacement. This value is of displacement, and the other part is you have figured out the direction as well. So it goes from this point to this point. Now we can, still refer it to like this would be in northwest kind of direction. So if you want to write that, that's also okay. If you just have to show this arrow, that would work fine. So is this understood for everyone?
Sir, I did not get that. How did you get to know that it is northwest?
Because, see, this is my arrow here, right? I'll help you with that. So if I started off here, where I actually started off with, that was north, right?
Yes.
Then this was east, and that's south, and this should be west, right? So if you
Yes.
focus on where this green line is going, so it's kind of
Mm.
somewhere between north and west, right?
Yes.
So that's the reason I'm writing Northwest. However, one other thing which some of the students they think of is, sir, can we write, these angles if we want to? So yeah, you can do it as well. If you have a protractor, just write this angle that would specify the direction. As in, in maths we do bearings and all. You guys get this?
Yes. Yes.
That's nice. That's
Okay.
So I'll share my, drawing which I've done on your groups, so you can have an idea of how it should be, done physically. So we have a group here. Yeah, I've shared the drawing on your WhatsApp groups. You can, get an idea of about how it looks, and then we can move ahead. So basically, we have learned a very important idea here. That was how to go about dealing vectors. Now, if the same question asks us, okay, what's the total distance traveled by the car? So the total distance traveled by the car would always be, just treating up these values, and we are going to get 800 meters. That's the total distance. Okay. Okay. Now, let's do another example. So if we have, let's say a plane that flies north 500 meters from city A to city B, then it flies 200 meters west from city B to C. So calculate the total Part A, distance traveled by it, and B, displacement. So give it a read and suggest me how do I go about it. So first thing is, if we want to work out for distance, so it's simply 700 meters, right? That's because we have had like 500 meters with 200 meters. We don't have to account for any directions, whatever is written in the question, because distance is a scalar concept. So it's just like 700 meters. That's the answer. But if we go about displacements, so we have to account for the directions as well. So now, there is one more thing, and that's new thing which you can, kind of figure it out here is that I'm having north and I'm having west as my directions, and north and west happens to be exactly at 90 degrees to each other, right? So if this is 500 meters and that's 200 meters, so I don't have to necessarily, sketch it, measure it, draw it. I can just treat it with the right angle triangle and figure out that's hypotenuse. This is if that's the angle I'm working for. So this becomes adjacent. This becomes opposite. So I can just use which theorem was it?
Pythagoras theorem.
Pythagoras.
Pythagoras theorem. So we can work out hypotenuse. That would be adjacent. That's 200 squared plus opposite. That's 500 squared. And then we can work out hypotenuse. And let's see the answer. What's your answer here? So 200 squared plus 500 squared. So it comes out to be 538.52 meters for me, right? Do you guys get this?
Yes, sir.
So that would be the precise direction of this. That's north and then west. So this is somewhere here. So we can just draw it like this and move about it. That's nice. Zara, that's nice. That's nice. Good job. So there is one more thing, now this should be a confusion. So when do we draw and when don't we draw? So there is a trick and there is a special key to it. When you are given the two vectors, okay, when you are given the two vectors, so you should think about any trigonometric function which you can use the way we treated it with this. But when you're given it more than two vectors, I'll always recommend draw, just like here. There were three vectors: 100 meters east, one displacement, one vector; 200 meters north, that's second; 500 meters west, that third. So there are three vectors. There are not two vectors. So we have to draw. We cannot do anything other than drawing this. Here, we can, approach through a different idea, but still we can draw it and we'll get the same answers as we just did. Okay, is this understood to everyone?
Sir, I have a question.
Yeah, sure.
Sir, if there's two values given and they are opposite values, like
Yeah, I was just coming to that. If there's same direction and opposite direction, what should we do? That's the next example you're dealing with. Other than that, everything is clear, right? That's nice. Good job. So what if we have something like this? So let's say a boy travels right. I'm intentionally, writing right because direction can be specified by anything, right? 500 meters, then it traveled, you know, left 300 meters. So the total displacement, what would be the total displacement of the boy? So his total displacement would be, you can work out 500 meters. That's right. Coming back 300 meters, that's left. So total displacement is actually this. So that's 500 minus 300. That would be 200 meters. Now for this, you have assigned this direction as positive. However, on the other side, you can still end up with minus 500 plus 300. So that would be minus 200 meters, and that would be assigning this direction as positive. So both of these answers are equally correct. And yet we never had to draw anything. Why? Because the directions were exactly opposite to each other. Do you get this?
Yes, sir.
चलिए साइंस वाले दोबारा से एक्सप्लेन कर सकते हैं
देखिए, साइन में आपने ये समझना है कि किसी भी एक पर्टिकुलर डायरेक्शन को आप पॉजिटिव ले सकते हो। अब थोड़ी सी इसमें अगर हम मैथ्स की हेल्प लें ना, हम अगर ग्राफ बना रहे होते हैं, राइट? So we have this habit of assigning this as positive and this as positive, right? And these two are negative x's. So this is your, understanding for graph. So if you use it here, so 500 meters right would be taken as positive. Or if you want to avoid it, then okay, we can go with 300 meters as positive. So it is your choice, whichever direction you want to take positive. राइट पॉजिटिव ले लें, लेफ्ट ले लें। अगर राइट पॉजिटिव ले लिया तो फिर लेफ्ट नेगेटिव लेना पड़ेगा। अगर लेफ्ट नेगेटिव पॉजिटिव ले लिया तो राइट नेगेटिव लेना पड़ेगा। आप पॉजिटिव ले लें, डाउन पॉजिटिव, आपकी मर्जी है, कोई मसला नहीं है इसमें। ओके, यू गाइस गेट दिस? Okay, that's nice. Acha. Now this was all about speed, sorry, distance and displacement. Now we are going to learn, a new concept, that's speed. And in your O levels, they're going to confuse the speed with total speed. Sometimes they will say average speed. Sometimes they will only say speed. So all of these things are basically same. Treat them same. These are just terms to confuse you. They're all same. So what's the speed? It's total distance traveled per unit time, or it's like rate of traveled distance. So in physics, we say anything once it is divided by time as rate. So rate means that's distance upon time, and the representation is v. That's the representation. And then the unit is meters per second. Now there is a very important catch and understanding here. We say that the unit is meters per second, but questions can deal with kilometers per hour, sometimes they do kilometers per minute. So basically, you don't have to memorize that the answers, if you're calculating speed, should always end up in meters per second. No, that's that's the standard or international, unit. But we can also have speeds in kilometers per hour or kilometers per minute, and that would be totally acceptable. There is no problem in that. But at times you have to convert between meters and kilometers. So for that, you can note it somewhere because that's very important. 1 kilometer has 1,000 meters. So if you are going from kilometers to meters, just multiply it. If you're going from meters to kilometers, just divide it. Similarly, everyone knows the conversion of hours and minutes and seconds. So that's 1 hour is 60 minutes. And then if you want to convert between seconds an hour, so that's going to be 3600 seconds. Just give me a minute. I have to plug in my charger. Okay. So the understanding is speed is distance per unit time, and we have talked about the units. Also, since we have already discussed the nature of the distance, that was a scalar concept. So beta speed is also a scalar concept. We don't have to have any direction problems, right? So let's do some questions on this. Yeah. So this is one of the good practice worksheets we had discussed so far. So let's try to solve question one. It says a train begins a journey from a station and travels 60 kilometers in 20 minutes, right? So what's that? That's distance. What's this? That's time. So it says what is the average speed? So we've just learned the formula speed is distance upon time, right? So now what do I do? I need to see the options I'm having with, they say give your answers in meters in per second, right? So I have to convert this kilometers into meters. So I multiply it with 1,000. So now my distance is converted into meters and then minutes to seconds. So let's time it with 60. This goes here, this goes here, and then my answer comes out to be 50 meters per second. ठीक है? Do you guys get this? Is this understood? Was it difficult? So is this a yes for being difficult, or is this a yes for you understood it?
Sir, I understood it.
Mhm. Okay. Then let's try question two. So, okay, that's nice. So question two talks about a car travels at an average speed of 60 kilometers per hour for 15 minutes. How far? That means they want us to find out distance. So the formula for speed included distance over time. So distance should be like speed times time, right? So speed here is expressed as kilometers. That's 60 kilometers per hour, right? But thing is, time is having a mismatch. Time here is in minutes and speed here is in hours. So what you should do? So think about it. It should be kilometers per hour, right? And it would be better to convert minutes into hours, or it would be very simple to convert minutes into hours. So 15 over 60, that gets converted into hours. So we can just cancel hours out, and then we can have kilometers. So it's like 60 here, 60 here, gone. So it's like 15 kilometers. Do you guys get this?
सर मेरे पास कुछ और आ रहा है.
है क्या?
I'm getting 240 kilometers.
15 divided by 60 is 0.25
Yes.
of an
And then
hour.
I divide 60 and
No,
0.25.
no, no, no. You have to multiply. Why are you? I think you're calculating speed. They want us to find out distance.
Oh, yes, okay.
Yeah, that's nice. We sorted this out. That's the now. Just read question three, and I can advise you that you have to be cautious. There is something wrong with that. Something confusing. Something kind of tricky about it. So let's see who was understanding the class, understanding the starting, and let's see who was not more into it. So I'm saving this here as well, but I know. Yeah. Okay. So now, if we talk about what happens here,
Sir?
Yes.
Sir, I did not understand question number 2.
Question number 2.
Yes.
Okay, and which part is basically causing trouble to you in question 2? Can you please let me know?
Sir, speed into time is the formula for distance, right?
Speed into time is the formula for distance. Yeah, yes, that's correct.
So for speed, what do we take? What value do we take?
For speed, what value do we take? That's 60 kilometers per hour. That's speed.
Okay, and we multiply by 15.
Yeah, we don't multiply it with 15, we multiply it with,
15 over
0
60.
point, yeah,
Okay.
that's 15 over this.
Okay, okay. Thank you, I got it.
So you get it? That's nice. Let's move ahead then with question 3. So question 3 talks about a car travels 100 kilometers. Okay. Okay. And then what's next? Yeah, why am I having this? You give me a minute. I don't know what's wrong with this. Yeah. So that's 100 kilometers and it takes 2 hours, right? Then it says the highest speed of the car is 80 and the lowest speed is 40. What is the average speed? Now there is a catch. Most of the candidates they think, okay, we have 80 kilometers per hour and we have 40 kilometers per hour. So they want us to find out average speed. This is one speed, that's another speed. So why not just add them and divide by 2? Okay. So that would be incorrect. Why? Because I told you specially that here you'll get 60 kilometers per hour, and there is, no such thing like average speed calculated this way. Average speed is always total distance upon total time. So it initially says in the question that's 100 kilometers of distance traveled in 2 hours, right? So that's time. So the answer should be 50 kilometers per hour. Now, what I want you guys to understand here is, see, your CI also gives you the wrong answer, which you might calculate. So please take a very important note of caution. Okay, we have to work out average in the other manner as we talked about in the definition original. You guys get this part? Is this understood?
Yes, sir.
That's nice.
Yes.
Sure. No. So I think that's enough for the questions. Let's move on to where we originally were. So yeah. Now the other concept is velocity. So velocity is exactly a vector quantity. So it's like we talked about, displacement and distance wala scene. वैसे ही है exactly velocity or speed wala scene. So if we are talking about speed, in a specified direction. So this becomes actually velocity. So everything is same, unit is same, that's meters per second. Representation is same, that's V. But thing is now it's not distance upon time, it is displacement upon time. So some of the, authors, they also define velocity as rate of change of displacement, or sometimes they say it's like total displacement covered per unit time. So it basically means the same regardless of you write here, this thing or that. Okay, is this understood? So there is no special formula for it. It's like same, the only thing is we cannot calculate velocity only by, using numbers. We have to have a specific direction as well. So if we, go about it like, so for example, there is a car that travels 500 meters per second, travels at 500 meters per second north. then turns, east at 200 meters per second. Calculate the, you know, resultant velocity. So how do you go about it? Any suggestions? So it's like, again, drawing thing, maybe Pythagoras theorem, 500 meters north, and then east. That's 200 meters per second east. So this is what they're interested in, right? So you don't have to actually draw it, two vectors in. You can use Pythagoras theorems to work hypotenuse out. Is this understood?
Yes, sir.
Just give me a minute, let this azan end, then we'll resume. Yeah, okay. So we are back. So this is basically velocity. Now, what we can, relate velocity with is basically acceleration, which is very important for us to understand. So acceleration is defined as rate of change of velocity. That's the most simplified and one, line definition of acceleration, and that's the only definition. It's not rate of change of speed, it's like rate of change of velocity, and you have to keep this in mind. Now, since velocity comes up with two things, that's a magnitude and a direction. So if any of these two changes, because they are talking about change, so if any of these two changes, velocity changes and then acceleration changes. So for example, if we talk about you know what would be change in magnitude of velocity, so it's like if we are having a car that is started at rest, and then it moved to somewhere here, and right now it is maybe moving with 10 meters per second. So initially, since it was at rest, so we can write u as 0 and v as 10. Now what is this u represent? So there is nothing to worry about. Just tell me what was this v to represent. So v was actually representing what? Either speed or velocity, right? Do you guys remember that? So, this V was representing speed and velocity. Yeah, we did that. Now, basically, this car was starting from rest. It was never moving at all. So initially, it had some kind of different velocity or different speed. But when it started to move at a certain time, after that, it ends up at 10 meters per second. So right now, car is moving with a velocity or a speed of 10 meters per second, right? So initially, it was different. So in order to, differentiate between two different speeds or two different velocities of the car, I came up with using u to represent initial velocity and B to represent final velocity. It's like, or in alphabetical sequence, U comes before V. So let's use U to represent initial velocity. Do you get this part? Okay, that's nice. So the other thing is, how do I represent change? That would be change as V minus U divided by time. So it would be, 10 minus 0 upon time. Let's say we can assume from 0 to 2, it took 2 seconds. So time would be 2. So we are going to end up with 10 over 2. That's 5 meters per second squared. And the acceleration would be in the direction of velocity, since it is a vector concept. That's one of the things. The other thing is, if we happen to have a change in direction only, will that have an acceleration? So answer is yes, absolutely. So in this example which we just did, car was initially here, it traveled in this direction and it kept on moving in this direction for 2 seconds, and it reached up 10 meters per second. So there is initially no change in direction. So there wasn't any change in direction, yet the car had an acceleration. That's what's important. Okay. Now, if we say if that there's a car that goes, to turn around a roundabout, maybe there is a circular track, and then there is a car that moves like this in a complete circle. While it is moving in a circular path, so the driver is constantly traveling at 10 meters per second here, 10 meters per second here, 10 meters per second here, 10 meters per second here. So we can actually see that there is no change in speed, right? There is no change in magnitude. It is still, same at every point in this circular motion. But what's happening here is that, at every point under consideration, the car is going in a different direction, right? So now what I want you guys to understand is that this car is changing its direction at every point in a circle. So yes, there is an acceleration here. Why? Because acceleration is dependent on direction as well. So if direction is changing, then we can have a change in velocity, and then we can have an acceleration as well. Do you guys get this part? Is this understood?
Sir, can you repeat one more time, please?
Yeah. So let's imagine, you're sitting in a car and that car has to turn in a circular path. Okay. And for the time being, that car is traveling at the same speed. It is neither increasing its speed nor decreasing its speed. It is all, at different points in that circular path, it is moving at the same value of speed, right? So what you guys need to understand here is, if, we talk about the direction of the car here, direction of the car here, direction of the car here, direction of the car here. So is direction same at all points or is it different?
Different.
That's nice. Direction is changing, right? So we talked about acceleration as change of velocity per unit time, right? And then I'm saying that this car is experiencing an acceleration because this velocity is a vector concept, and vectors, they change when direction changes, right? So this car can have an acceleration. Okay, this is experiencing acceleration. Why? It is not because, value of speed is not changing, or magnitude of speed is not changing. It is because the direction is changing at different points. If you calculate, 10 here and 10 here and 10 here and 10 here, you might end up with 0 as your answer, right? But thing is, it's not acceleration is not 0 here. Why? Because acceleration is not only dependent upon the value of, speed, it also depends upon direction. So since direction is changing, this car is experiencing an acceleration. So anything that moves in a circular path experiences acceleration. One such example is gravitational acceleration, which we all experience. satellites, they move, uniform circular motion में होती है, सब free falling होती हैं. It's like that. Do you guys get this? Is this understood?
Yes, sir.
So anyone having any questions on this? No, that's nice. Let's practice some questions. So let's say there is a car that travels from 15 meters per second to 20 meters per second in 5 minutes. What's the acceleration of it? How would you work that out? So basically, acceleration was change in velocity over time. So velocity is 20 and 15 over time is 55 minutes, but we have to convert it into seconds. So that's 5 over 300, and that would be around 0.016 meters per second squared. That's the unit of acceleration. Acceleration is expressed in meters per second squared. Do you guys get this? Is this understood?
Yes, sir.
That's nice. So let's do another example. So there is a car.
Sorry to interrupt you, but why is this second square?
Because this is meters per second. This is meters per second. This is in seconds. So when you divide meters per second with second, you end up with meters
तो
per
सर
second.
अगर आंसर तो उन्होंने नहीं लिखना तो मार्क्स कटेंगे.
किस चीज के मार्क्स कटेंगे? क्या पूछ रहे हैं आप?
अगर आंसर में नहीं लिखा मीटर्स पर सेकंड स्क्वायर, बस मीटर्स पे वो लिख दिया.
सिर्फ आपने ये लिखा है, ये नहीं लिखा है आपने, तो ये नहीं लिखा तो 1 मार्क गया आपका.
नहीं, स्क्वायर नहीं लिखा, बाकी मीटर्स पर
नहीं,
सेकंड लिखा है.
देखिए ना, तो इसका मतलब है कि फिर आपने ये एरर किया है कि आपने एक्सेलरेशन को वही यूनिट दे दिया जो स्पीड का यूनिट था. तो स्पीड का यूनिट होता है ना मीटर पर सेकंड, इसका तो यूनिट मीटर्स पर सेकंड स्क्वायर होता है. तो 1 मार्क वुड बी डिडक्टेड. अगर आंसर 2 मार्क्स का था तो 1 मार्क मिलेगा. अगर आंसर था ही 1 मार्क का तो 0 मिलेगा. ठीक है. अगर आंसर 3 मार्क्स का था तो 2 मिलेंगे. It is very important for us to use proper units. Okay, okay. Now let's move on to another example. A car moving with 50 meters per second applies brakes and comes to rest in 10 seconds. Calculate its acceleration. So how do we go about it? So it would be like, v minus
50
0.
minus 0.
जी नहीं. This was initially it was traveling with this, then it applied brake and came to rest. So finally it's 0. So it would be 0 minus 50 over 10. So it would be minus 5 meters per second. So that's the acceleration. That's the acceleration. Do you get it?
Sir, how can it be a negative
Sir,
value?
can you explain?
Because initially the formula is final and then initial. So if you read the question, car was initially moving with 50, right? It then came to a stop. It was never reaching up to 50. It was initially moving with 50 and then it applied brake and then it came to a stop. So finally it rested, right? Do you get it? You cannot just switch positions with your understanding. You need to understand what question says here. What was V? V was final velocity. What was U? U was initial velocity. So if you reread the statement, you'll come to know initially it is moving with 50, then something happened, brakes are applied, okay, so it came to rest. Do you get it? So this example basically, helps us to identify that acceleration can either be positive here, as it was, and it can also be negative here. But there is one more thing that's here. Negative acceleration is given a specific name, and that's deceleration or retardation. So basically, deceleration is negative A. Negative A is negative acceleration. So acceleration can be positive and it can be negative. So let's say if there is a question that says a cyclist was moving with 5 meters per second, applied brakes, and slowed down to 1 meter per second in 2 seconds. Part A, what's the acceleration? So how would you do that? Part B, what's the deceleration? How would you do that? So let's think. We haven't done any formula for deceleration. Okay, let's leave that alone. We have done acceleration. That was final velocity minus initial velocity over time. Final velocity is 1, initial velocity is 5, time was 2. So that's 1 minus 5, that's minus 4 over 2, that's minus 2 meters per second squared, right? So that's the acceleration. Do you get it? Is this understood to everyone?
Yes.
Then we have what? Then we have then we have part B, that's part A, and then we have part B. Part B is basically deceleration. So how do I calculate deceleration? Deceleration is negative acceleration. So it's like, okay, we ended up with -2. That's already negative acceleration. So deceleration would be only 2 meters per second squared. So you have to very carefully observe the sign here. Plus, in case of calculating deceleration, minus in case of calculating acceleration. Do you get it?
Sir, can you please repeat?
Yeah. Deceleration basically is negative acceleration. Okay, that's the concept. So in part A, we calculated acceleration regardless of the sign. If it is coming out to be positive, it stays positive. It is coming out to be negative, it stays negative. So we did, A. But in part B, we don't have to calculate anything. It says deceleration. And conceptually, deceleration is negative acceleration. I just told you in the last class, last slide. So we have, this negative sign with us, and then we calculated acceleration as -2. So originally it became +2. So whenever they ask you to find out deceleration, what you need to understand is deceleration is itself negative. So you don't have to, keep another negative on deceleration. So deceleration always is positive. However, acceleration can either be positive or it can either be negative. You get it now?
Yes, sir.
Are you sure?
Yes.
That's nice. That's great. Okay. So any questions anyone having right now? Any doubts? Any confusions?
Sir, can you share some like practice questions so we can practice?
Yeah, definitely you're going to get those questions. Don't worry about it. Now, I want you guys to have an idea about, graphs as well. So let's talk about, if we have distance time. So one of the possibilities is we can have a graph like this. We can have a graph sketch like this. We can have a sketch like this. So what does these, three graphs show? The first thing is the graph here shows object at rest. Now, why is it at rest? Because you can see that there is an object here, then here, then here, then here. So whatever was the distance here, it stays the same at all different points, right? So if it was 5 here, it stays 5, 5, 5. If it was 10 here, it stays 10, 10, 10. The object is not moving at all. That's the reason that the distance of the object is not changing, right? Had it been changing, so you could expect something moving like this, or something more like that, something like that. So do you guys get this? What does this mean? Yes or no?
Yes, sir.
That's nice. Okay, now what does this show? So obviously this is showing, object moving, but we need to be more precise. How is it moving? Is it moving with acceleration, without acceleration, what? So basically for that to work, for that understanding, what we need to calculate is the gradient. That's like M. Now, what's the gradient? Gradient is basically rise over run. Okay. So rise is distance. That's y-axis and then time. So rise is distance and run is time. So what's the ratio of distance upon time? Isn't it a speed? So yeah, that is the speed. So the gradient here shows the speed. So the object here is moving, and it is moving with constant speed. Why is that so? Because gradients, for straight lines, they don't change. So since it is a straight line, so there is no change in gradient. So it is moving with constant speed. अब I think ये थोड़ा सा maths वाला part है, but आपको आता होगा. तो मैंने इसलिए direct लिख दिया. Is this getting into your head, or you feel it challenging? पता नहीं क्या है.
No, sir, ये आसान है. हम last year भी हमने ये पढ़ा है.
That's nice. That's great. Zabardast. Similarly, if we have something like this, now what does that has to mean? So obviously, something like this isn't possible physically. This device or this object is moving, it is covering a hell lot of distance, increasing, and time is not changing. So it's basically moving with kind of क्या कहना चाहिए, moving with infinite speed, where you don't have anything to do with time. So it's like, moving like energy where time doesn't make any sense. So that's what, just for fun here. That's not possible at all. Okay. Do you guys get this? Is this understood?
Yes, sir.
Yes, sir.
Okay. Then I have received a message from, जो काम होता है कुछ लोगों का, वो ये काम होता है, कुछ बच्चों का ये कंसर्न था कि सर संडे को पढ़ा रहे हैं. तो अब आई डोंट नो आप उनको कैसे टैकल करोगे, जो दूसरे बच्चे हैं जिन्होंने क्लास ली है. तो प्लीज टॉक टू देम, क्योंकि मैं तो आऊँगा नहीं मंडे को. तो उनसे बात करो कि यार अगर टीचर संडे को पढ़ा रहा है तो टीचर ज़्यादा मसरूफ होना चाहिए ना, तुमसे ज़्यादा तो मसरूफ टीचर हो. So class was kept just for your just for helping you to score good marks in your test. So अगर मुझे इस तरह आप तंग करेंगे ना, तो फिर मैं क्लास नहीं रखूंगा. अगर मैं नहीं रखूंगा क्लास, येट आई डोंट फील डिस्टर्ब बाय स्टूडेंट्स. उनकी बातों को इतना मुझे कोई फर्क तो पड़ता नहीं है, क्योंकि अगर मैं इस तरह सोचूंगा तो कोई भी बच्चा कभी भी क्लास लेने में इंटरेस्टेड नहीं होता. लेकिन थोड़ा सा अगर हम एज अ टीम बिल्डिंग करें ना, यानी कि व्हाट आई वांट यू गाइस टू डू इज टू, कि यार आप क्लास लो, आपको फायदा होगा, आपको फायदा होगा, आपका स्कोर अच्छा आएगा. दैट इज इट. फजूल में आर्ग्यूमेंटेशन, फजूल में क्योस, उससे सर का तो कुछ बिगड़ेगा नहीं. सर ने जब भी रखनी होगी, संडे को रखें ना रखें, दिन में रखें रात में रखें, सर रखेंगे. सर को आप नहीं हटा सकते ना. आपको क्लास लेनी चाहिए ताकि सर भी मोटिवेटेड होंगे. यार 50 बच्चे थे क्लास में, 20 बच्चे थे क्लास में, तो मज़ा आता है उसमें ना. ठीक है. तो टॉक टू देम, स्पीक टू देम, इसलिए नहीं कि मैं ऐसे कह रहा था इसलिए कि यार उनको थोड़ा सा कुछ कॉमन सेंस प्रिवेल करना चाहिए, बजाय इसके कि सिर्फ हर वक्त हम क्रिटिसाइज करते रहे चीज़ों को, तो उससे कुछ नहीं होता। अच्छा, इसमें एक ट्विस्ट भी लाते हैं। ट्विस्ट इस तरह का लाते हैं कि हम ये कह रहे हैं कि इफ वी हैव समथिंग लाइक दिस, व्हाट हैपेंस नाउ, व्हाट डज दैट मीन? सो फर्स्ट थिंग इज, this is an increasing gradient, right? So object here is moving with, क्या कहना चाहिए, what was gradient per distance time? So that was speed, right? So object is moving in increasing speed. That means it is accelerating, isn't it? Increasing speed, change in speed. Now, what if we have something like this? That's distance time. So what happens here? So that's decreasing gradient, right? So that's moving with decreasing speed. And that's deceleration. Do you guys get this? Is this understood?
Yes, sir.
Yes, sir.
So far what we have done is distance time वाला काम किया हमने, ठीक है? तो बाकी फिर जो speed time है वो चला था, बाद में करेंगे. I hope this helps. I hope now everyone scores 100% in the test. I'll definitely share some questions so that you get to know about past paper questions. I think test Tuesday को तो नहीं होगा ना?
सर ट्यूसडे को है.
अबे यार, ट्यूसडे को टेस्ट? अच्छा, चलो फिर एक काम करते हैं, फिर मैं क्वेश्चंस आज या कल में भेज देता हूँ. तो क्वेश्चंस के लिए फिर अगर कोई डाउट होगा ना, तो वो ग्रुप पे या मैसेज पे डिस्कस कर लेंगे. तो फिर कल उसके लिए ऑनलाइन क्लास रख लेंगे ताकि कुछ पास पेपर्स भी हो जाए ना. ठीक है, क्या कहते
सर मेरे पास एक क्वेश्चन है और ये बहुत अच्छा आइडिया वैसे.
हैं?
सर आप कहते हैं कि डिसेलरेशन जो है वो हमेशा पॉजिटिव होती है,
या
लेकिन अगर हमारी एक्सेलरेशन जो है वो पॉजिटिव आई है और अगर हम उसे नेगेटिव से मल्टीप्लाई करें तो वो तो नेगेटिव आएगी.
देखिए ना, अगर एक्सेलरेशन पॉजिटिव आई है मेरा बच्चा, तो वो ऑब्जेक्ट तो एक्सेलरेट करा होगा ना, उसको हम नेगेटिव से मल्टीप्लाई क्यों करवाएं? मतलब मैंने
तो उसकी
आपको,
डिसेलरेशन है ही नहीं आनी.
हाँ जबरदस्त,
ऑलराइट.
जबरदस्त. तो इसको समझने का देयर इज वन मोर बेटर वे. देखो, अगर एक रिएक्शन है, केमिकल रिएक्शन की हम बात करते हैं, उससे ज़्यादा अच्छे से समझ में आता है, क्योंकि वो बहुत अच्छे से समझ में आया बहुत है ये कॉन्सेप्ट. ये वो अकेला कॉन्सेप्ट होता है केम का जो सबको समझ में आता है. व्हाट डू यू मीन बाय एक्सोथर्मिक एंड एंडोथर्मिक? सुना है कभी?
Yes, sir.
यस.
एक्सोथर्मिक में आप कहते हो एनर्जी रिलीज हुई है ना, तो आप
यस.
एनर्जी की वैल्यू के
Yes,
साथ
sir.
नेगेटिव लगा देते हो, -100 लिख देते हो या -200 लिख देते हो ना. तो अब अगर एक रिएक्शन एक्सोथर्मिक है, तो भाई वो एंडोथर्मिक तो नहीं हो सकता ना.
नहीं.
No, sir.
समझ लो, सिंपल है, या तो एक्सो होगा या एंडो, तो टू अपोजिट्स कैन नॉट कोएग्जिस्ट. तो या तो एक्सेलरेशन
ऑलराइट.
या डिसेलरेशन हो. ऐसे थोड़ी होगा कि एक्सेलरेशन भी और डिसेलरेशन भी है, ये नहीं हो सकता. ठीक है, तो अगर एक ऑब्जेक्ट है विच इज एक्सेलरेटिंग और क्वेश्चन पूछता है व्हाट इज द डिसेलरेशन, तो भाई डिसेलरेशन इज नॉट माइनस विद द सेम वैल्यू, इट इज जीरो, बिकॉज डिसेलरेशन है ही नहीं उसमें, तो एक्सेलरेट कर रहा है. ठीक है, वी गेट इट. So I'm going to share these slides with you guys so you can have an idea कि हमने क्या किया है. ठीक है, बाकी बातें इंशाल्लाह ताला पासिबल वाली मैं भेज देता हूँ और वो कर लेते हैं. So चलो, let's end this. Okay, let's end this. Take care. Allah Hafiz.